Hello everyone. I'm Nicolas Sallet. I'm developer for Odoo for 10 years now. I'm a member of the Odoo internal team. The Odoo internal team is in charge of maintaining the Odoo.com platform in all its aspects. And the subject of today will be to try to set up multiple PostgreSQL servers behind the same Odoo instance and try to split the load across multiple PostgreSQL servers. I will have a small introduction and I will try to convince you why you don't need this, and then I will try to explain you how to achieve it. At the end of the talk, it's possible for you to ask questions, so feel free to go to the pad and fill the pad with your questions, and we will answer the questions at the end of the talk. So the most frequent situation you will find in the Odoo world is you have one server on premise. You have one server. On this server you have one Odoo instance and a PostgreSQL instance, and your Odoo instance is connected to your database in PostgreSQL. You only have one server, and when you need more power, you can just add CPU or RAM to the machine. It's very easy to maintain. And what we will try to achieve now is having multiple Odoo servers which are connected to multiple PostgreSQL servers. That way we will be able to add new servers when we need more power. And the tricky part is we should still be able to write a data within an RPC call, and just after we use another RPC call, and we should be able to read the exact data we've just written. So, how to achieve this with version 19, and what's new with version 19? Up to now, this is the most complex situation you could achieve with Odoo. You can have multiple database servers. Those database servers are a copy of each other. Then in case of emergency, you can switch from one server to the other server. But all Odoo servers are connected to the same PostgreSQL servers. And the connection between Odoo and the PostgreSQL server is a read and write connection. The aim of this talk is to explain how to achieve this. In version 19, if you replicate correctly your PostgreSQL server, you are able to connect all your Odoo server to one main server, which is the only one that is able to read and write the data. And you are also able to connect the same Odoo instance to another PostgreSQL server just for read operation. This way, we should be able to split the load between the read-write server and some read-only servers. The second part is, do you really need this? First, try to not over-engineer your system. The system will break when you are on holiday, during the night, when you are drunk, when you have no laptop. This will not break when it's Monday morning and you are fit at the office. No. So beware prior deploying this kind of solutions to not over-engineer because it's cool. You should only do that as a last resort. If your code is ON square, it will not work better with bigger servers. So first of all, you need to have a good Python code. Also, prior splitting the load between different database servers, ensure that the database is already clean. You have the necessary index, you have the correct storage, you have the correct configuration of the server, etc. And it's not possible anymore to scale up the server you are using. If your database is running on a Raspberry Pi, maybe there are other solutions rather than putting another Raspberry Pi in addition to the first one. The difference between vertical and horizontal scaling for the database. By vertical scaling, I mean having a bigger server. Horizontal means adding more servers. The advantage of the vertical scaling is you do not add complexity to the system. You still have the same system. It's not more complex because you have more CPU or more RAM. The problem is you need big and bigger hardware. It's quite easy to maintain, but it's very hard to resize because you need to copy the whole database, you need to copy the configuration, not miss anything. On the other side, for the horizontal scaling, the configuration is quite complex, but it always requires the same hardware. If you need another server, you will put the exact same hardware in addition to the previous one. It's quite harder to maintain, but it's way easier to resize. So the main advantage of keeping the vertical scaling is you keep something everybody understands. The advantage of the horizontal scaling is you can scale up to what is possible in your data center. That said, you are convinced you need to deploy this solution. Let's configure PostgreSQL to achieve this goal. To achieve this, we will use only vanilla PostgreSQL. So everything we will use is built in PostgreSQL. You need no external software, only PostgreSQL. We will use the streaming replication between the different PostgreSQL servers. And we will see the difference between a synchronous replication and an asynchronous replication. No matter what we are doing with that, there is only one server which will be able to write data. You can have as many servers as you want to read the data, but only one of them will be able to write data. It's not at all a way to use smaller PostgreSQL servers. Each server owns the entire database. That means each server should have enough disk to store the database. That also means each server should have enough memory to put as much as possible data in the memory rather than on the disk. The more data you have on memory, the better. The less you have on memory, the more the server should read on disks, and it's quite slower to read on disk rather than memory. So it's not a way to split the database across different servers. You will just split the CPU load across different servers. And you will also split some disk I/O as well. So we will not use anything other than PostgreSQL itself. It's not a multi-master solution. And the latency between the different servers will be very important. What does mean synchronous or asynchronous replications? Asynchronous replication is the mainstream replication in PostgreSQL. It means that when you write something on the PostgreSQL servers, Postgres will send to other servers what should be modified on them to keep track. In a synchronous replication, when a server is writing something, it will also write it immediately on the other servers. And the application which use the commit instruction will only get the return once the commit is done on every server and each server. So the latency will be very important here. If you choose to use your bunch of PostgreSQL server as a synchronous replicated bunch of PostgreSQL servers, you also need some asynchronous PostgreSQL servers which will be member of the replication. The problem is, in this situation, when one PostgreSQL server dies, PostgreSQL require to commit to a given number of servers. In this case, it should commit to 3 servers, and one of those 3 servers is not available anymore. So what PostgreSQL will do is, taking one of the asynchronous nodes, raise the level of the asynchronous node to the synchronous level, and leave the dead one aside. To switch from synchronous replication to from asynchronous replication to synchronous replication is as complex as adding those 2 lines of configurations. When you have a replicated cluster of PostgreSQL, you add those 2 lines in the replication, then the main server is aware that he is a member of a synchronous replicated bunch of servers, and he gets a list of servers. You can either use an ordered list of servers or an unordered list of servers. It's quite easier to use an ordered list of servers because when you use an ordered list of servers, you know which servers will be used first when one of the members will die. In this case of the configuration, we have a master server, we have 3 potential secondary servers. We will use 2 secondary out of those 3 potentials, and it will use in priority PG2 than PG3, and if one of them is unavailable, it will use PG4. In this case, I have 4 servers, a main server, 3 secondary servers. If I lose 2 servers, the PostgreSQL cluster is down because you are not anymore able to commit to enough secondary servers. I insist on this because the aim is to improve the system reliability and performance, but by switching from asynchronous to synchronous replication, we put ourselves in a situation where we have more situation where the cluster can be down. So prior to switching to synchronous replication, I really advise you to monitor your system and ensure everything is working. I ask you to keep track of the asynchronous replication and switch to synchronous replication when you really know you need it. I hope I've been clear enough on this point. Okay. We now have a bunch of PostgreSQL which are synchronously replicated each other. How can I configure this in Odoo? Quite simple. This is the default configuration for Odoo to connect to one database. We have simply added 2 parameters, the host and the port, to the replica, to the synchronous read-only servers. That's what we have added in the command line. We do not need any user or password for the secondary because the whole cluster, the whole database cluster, is replicated from one server to the other. So the users are exactly the same for the main server and the secondary server. Each call to PostgreSQL from Odoo to PostgreSQL is a transaction in PostgreSQL. You cannot write something on a read-only server. This will fail. And we would try to avoid as much sending read-only queries or transactions to the read-write server. Add a call to Odoo is a transaction. Everything, all queries from one Odoo call should be done on the read-write server or the read-only server. You cannot do some queries on one server and some queries on the other server. It's all or nothing. So the key point is to identify as early as possible what could be sent to the read-only server. If you are using save points in your code, it's the evil. You should remove all the save points in your code to use this kind of replication. And as I said, you cannot split the Odoo transaction between the read and the write node. What happens if the secondary server dies? If the secondary server dies, Odoo will close the connection to the secondary and send all requests to the read-write server. There is a parameter which controls after how many times it will retry the connections. This parameter is set by default to 20 minutes. So after 20 minutes, Odoo try again the connection to the read-only node. When the workers are recycled, the new worker is not aware if the secondary server die or not. So it will also try to connect to the secondary server. To identify early what we can send to a read-only or a read-write transaction is on the web controllers. On the web controllers, you have a parameter called read-only, and if you set it to true, the system will try to send a request to the read-only node. By default, it's false, of course, and the whole transaction will be done on the read-only node. If at some point the server tries to write some stuff, there will be an exception. You will see this exception in the logs, and the system will retry the whole transaction on the read-write node. So instead of winning time, we will lose time, because we have said that a read-only transaction is not really a read-only transaction. Another way to identify early what can be done on the read-only server is on the model level. On the model level, you have the methods, and you have a decorator, which is API read-only. And if you use this decorator, it's exactly the same as for the web controller. The call will be tried on the read-only node. That's it. We have achieved the configuration of PostgreSQL and Odoo to do read-only queries on the read-only node and the read-write queries on the read-write node. Thank you. If you have any question, feel free to ask, and I will answer them.
Thank you, Nicolas. Oops. Is this okay? Can everyone hear me? Hello, hello. Yep. Awesome. There are a couple of questions coming in. So why save points are evil first?
Because the save points get a transaction ID. And those save points are stored in an LRU. This LRU is 64 entries wide. At the 65th entry, it goes in a file. On the secondary server, he is not aware of the closed save points. So when you reach the 65th save point, the read-only server continuously check on the disk if there is a checkpoint or not. So the checkpoints, because of this save on the disk, kill the performance, because instead of reading in memory, he reads on disk continuously. That's what that's why they are the evil.
Thank you. Is this available on Odoo SH?
No. On Odoo SH, you can grow up to 256 CPUs on one node. So we have still not met a need for more than 256 CPUs on Odoo SH for just one Odoo instance. It doesn't split the database size. It's only a matter of number of CPUs. The disk, all PostgreSQL servers should handle the whole database size, the index, etc., the disk I/O, etc. So it's only a matter to split the load.
This relates to Odoo SH again, but thank you for your presentation first. Someone here running the instance on Odoo SH but would like to replicate the DB for BI purposes to the on-prem.
Yeah, the PostgreSQL port is not opened on Odoo SH. The other point is on Odoo SH, it's a shared hosting. That means the PostgreSQL cluster contains other database than yours. The replication is replicating the whole cluster. So we cannot let you replicate your database as well as the ones from the other customers. So it's not an option to let you replicate with the streaming replication PostgreSQL cluster hosted on Odoo SH.
Next question is, can I pass a list of secondaries or only one?
Only one, but this only one can be a DNS entry, and you can be DNS round robin. You can do whatever you want. You can use stuff like PG bouncer or whatever to split the load across servers, but mainly only one server, and it's already complex enough.
Someone answering the former question where you can actually download a backup daily with a script and restore for the Odoo SH on-prem question. Any work being done for attachments and sessions for horizontal scaling of the Odoo server ourselves?
No, because sessions and file store are just files. So scaling this, you can use software like Ceph or whatever to split your files across server. It's just a file storage. So no, nothing has been done on this area. And for the sessions, the OCA have a module which can store the session in PostgreSQL. So if you really have an issue with the sessions, the module of the OCA is called Sessions DB, and it stores the sessions in the database. I know this module because I was the author of the module.
What's your take on handle cache between Odoo and Postgres?
I don't know. I don't know what is Heimdall, so cannot answer this.
If you mind to maybe correct. How can we get your presentation? Well, that will be live on YouTube right after as well. Do you think there will be a solution to have several RW servers in the cluster?
No. There is if you search on the net, you'll see that many people want to achieve this, and because we have already achieved this and we saw the nightmare it is to achieve this, adding more right nodes in a cluster is really, really, really hard. If you search the net, you'll see that companies like Enterprise DB offer solutions for multi-master, but it's very niche and it's not something. When you reach this, I think you are out of the scale of what Odoo needs.
Can you tell us about how it was implemented for the standard code, or there are a lot of API read-only in Odoo 19 standard code, for example?
Yeah, you can just grab the code. It's open source, so yeah.
Are there already standard read-only annotations in the code, for example, for the F-Finance dashboard?
Some methods are obviously sticked as read-only in the code. Search, read, search read, web client read. all of those queries are already sticked as read-only. So by doing nothing in the code and just configuring a cluster, some queries will automatically go to the read-only server. And that's why it's important to clean the code prior to that, because if you have some computed field which will store stuff, your read-only method will go to the read-write server.
There was some more waiting, but we don't have any more time, so thank you all.
I'm available for 3 days, so feel
There
free
you
to
go.
come.